Find the general solution for the given differential equation z double prime minus 6z prime plus 10z equals 0. So they obviously just replaced y with z, we treat it all the same, and we need to create our auxiliary or characteristic equation such that r, or m if you want, can equal the amount of derivatives being taken on z. So z double prime is r squared, and z single prime is just r, and always include the coefficient, so minus 6r. And there are no derivatives being taken on z here, so it's just 10, and that equals 0. You'll quickly find that you can't easily factor this equation, so we have to rely on the quadratic formula, minus b plus minus square root of b squared minus 4ac over 2a, and a equals 1, b equals negative 6, c equals 10, and fortunately b is even, so we can use the simplified version where b prime equals b over 2, which is negative 6 over 2, and that's just negative 3. And that becomes negative b prime plus minus square root of b prime squared minus ac over a. You don't have to do this, it's just a lot quicker if you do. So plugging in these variables, negative b prime is just positive 3, plus minus, 3 squared is 9, minus ac, so 1 times 10, over a, which is just 1. So I'll just leave that out. Simplifying further, 3 plus minus square root of 9 minus 10 is negative 1. Again, this is for r, so r equals 3 plus minus I, where I equals rad negative 1. In the situation that the roots have a complex component, we have r in the general format of alpha plus minus beta I, where alpha is the real component and beta is the coefficient of the non-real component. We can quickly see from here that alpha equals 3, and beta just equals 1. Beta can never be 0, so it's just 1 times I. For the equation, we can set y homogeneous equal to z if you want. I usually just stick with y, but technically it's z, equal to e to the alpha t times c1 cosine of beta t plus c2 sine of beta t. And plugging in alpha and beta, we have y homogeneous, or z homogeneous if you want, e to the 3t, alpha equals 3, times c1 cosine of just t, 1 times t is t, plus c2 sine of t. We keep the c's to allow for infinite solutions, and that's all we have to do in this problem. If you have any questions, please leave in the comments below, and good luck.